Hello, in this video we'll present some examples about how to calculate the limits of functions of two variables. So we take the first example, f of xy equals x3 plus y3 over x2 plus y3, and we need to study the limit at the point 0, 0. Of course, the domain of definition of this function is R2 deprived of 0, 0, so we need to study the limit at a point that is not in the domain. So according to the previous video where I explained what's the procedure to find the limit, we'll start always by testing some directions. So we'll try some directions. First, let's take the direction according to x equals 0. Then we'll calculate the limit of f of 0, y when xy tends to 0, 0. So in practice, when y tends to 0. So it will be the limit of y3 over y3 because x is equal to 0, which is equal to 1. So that's one limit in one direction. Let's try another direction. We take y equals 0, then we are calculating the limit of f of x0 when x goes to 0. So when y is equal to 0, the function will be equal to x3 over x2, which is equal to x. Then the limit will be 0. So 1 is not equal to 0. That's why we have two different limits in two different directions. This will imply immediately that the limit does not exist and we don't need to look for other directions or for other proofs. It depends, of course, on the function we have, but we can test other directions like y equals x, y equals mx for other functions. Like if you put y equals mx, it means that if your limit depends on m, you still have nm in the expression of the function when you replace y by mx, then the limit will change with m, so you will have different limits in different directions. You can try y equals x2, for example, when you have something like x4 plus y2. So you test y equals x2 in order to have x4 plus x4. So of course these paths, these directions, y equals x, mx, x2, x equals y2, they all pass by the point 0, 0. That's why I'm proposing them. Because if your point is not 0, 0, you have to try other directions that go through the point where you are looking for the limit. Let's go now for the second example. F of xy equals xy2 over x2 plus y2. So we need also to study the limit at the point 0, 0, which is a point that is not in the domain. So again, we'll start by doing some directions. Let's try at the beginning x equals 0. So it will be the limit of f of 0y. So you replace x by 0, you'll have 0 over y squared. So that's equal to 0. Let's try another direction. If we take y equals 0, then the numerator will be 0 and the denominator will be x2. So 0 over x2, that's equal to 0 as well. So it seems that we are finding the same limit. Now you can try other directions like x equals y or whatever. So you see that we are finding 0 all the time. So the limit might exist. In the case that it exists, it will be 0, of course. It will be one of the limits that I found. So that's why, to prove that the limit exists, we will always try to calculate the absolute value of f of xy minus the eventual limit that we found for in the directions. So let's calculate f of xy minus this limit, which is 0. When we calculate this, our objective is to prove that this absolute value tends to 0 when xy tends to the point which is 0, 0. Again, it tends to 0, not to the limit, the value 0 always. So f of xy minus the limit tends to 0. So in this case, f of xy minus 0, that's f of xy in absolute value. So if it's x, y squared over x2 plus y2. But since we know that y squared over x2 plus y2 is always less than 1, because it's like a value over something bigger, so it's less than 1, then we can find that this absolute value is less than the absolute value of x, because we remove the part that is less than 1. And when xy tends to 0, 0, the absolute value of x, of course, it tends to 0. So we prove that f of xy minus a limit L tends to 0, or it's upper bounded by a function that tends to 0. But it's positive because it's in the absolute value. So it's lower bounded by 0, upper bounded by 0, so it tends to 0. And the limit of f of xy is equal to 0. So our objective is always to find an upper bound of this absolute value by a function that tends to 0. And that's one of the methods that we use, is to use the fact that y squared over x2 plus y2, whenever you have a numerator over something bigger than the numerator, so it's less than 1, so we can remove it and keep the remaining part. Let's take now this example where we have a function f of xy equals 3x2 plus xy over square root of x2 plus y2. So again, at the point 0, 0, which is not in the domain. So let's try some directions as usual. If x is equal to 0, the numerator will be 0. The denominator will be square root of y2. So it's 0 over square root of y2, that's 0. Let's try y equals 0. So the limit of f of x0 will be, of course, 3x2 over square root of x2. So you know at the denominator you have absolute value of x, and in the numerator you have x2. So you have 1 degree higher in the numerator. So you can simplify and the limit will be 0. So if you try other directions, you'll find 0 as well. So that's why we will say maybe the limit exists. Let's try to prove that the limit exists. But in this case, we will learn another method or try another method, which is the polar coordinates. With the polar coordinates, you will replace x by r cosine theta, y by r sine theta, and you will replace the fact that xy tends to 0, 0 by r that tends to 0. So let's do this. Polar coordinates, replace. So f of r theta will be 3r squared cosine squared theta plus r squared cosine theta sine theta over, of course, square root of x2 plus y2 will be r. So in this case, you can of course take r as a common factor and simplify it. So we lose the r in the denominator and we'll be left with r times 3 cosine squared plus cosine sine. So when r tends to 0, this will go to 0 because it will be 0 times something that is bounded, because cosine theta and sine theta are bounded. So this expression tends to 0 independently of theta. So even if theta can take any value you want, this expression will always tend to 0. Therefore, when the function tends to 0 for any value of theta independently of theta, this means that the limit exists and it's equal to 0. Finally, let's take this last example where f of xy is equal to x2y over x2 plus y2 plus xy. We'll discover here a new approach even to find the limit, or a new technique. So, of course, if we try directions, we'll find the same limit. So we will not try it right now. So we can just try x equals 0, y equals 0, etc. So we'll try immediately to prove that the limit is equal to 0. So we have to calculate, of course, the absolute value of f of xy minus 0, since we are not doing polar coordinates in here. So what's the absolute value of f of xy? That's the absolute value of x2y over x2 plus y2 plus xy. So we'll consider this new technique where we can take two different cases. The first one is if x is less or equal than y. The second one is when x is greater or equal than y. In fact, you can take any two cases you want, or more than two cases, as long as these cases cover the whole domain. So we take cases that cover the whole possibilities, and then if all of them takes me to a function that goes to 0, so the function will go to 0 and for any points when xy, then in any direction, I mean, when xy tends to 0, 0. So let's take the first case when x is less than y. Then if x is less than y, then if we replace y in the denominator by x, the denominator will be smaller, so the fraction bigger. So that's an upper bound of my absolute value. So this will be x2y over x2 plus x2 plus x2. So it will be, I can simplify the x2, so it will give me y over 3, which will go to 0 when y goes to 0. And if I take x greater than y, then I can replace in the denominator x by y, which will make a smaller denominator, so a bigger fraction. And this bigger fraction will be x2 over x2 plus 2y2 times the absolute value of y. But since I know that x2 over 2y2 is less than 1 for the same reason I spoke about before, it's because the numerator is less than the denominator, then my whole fraction or my whole expression is smaller than the absolute value of y, which goes to 0. So in both cases I went to 0. This means that the limit exists and it's equal to 0 as well.